Thank you everyone for joining today's call regarding AMD's industry-leading data center solution for CPUs. My name is Prasad Purushothaman. I'm Solution Architect for Ingram Micro IoT and AI division. Just to quickly go through the agenda, today we're going to cover the current processor markets and where AMD is placed in the current processor market, AMD's high performance computing solution that they offer. We're going to touch base on the new third generation AMD Epic CPUs, how AMD CPU performance is comparatively better than other competition in the market. We'll go through a quick overview about the Epic processor family, third generation family, and the options that are available today when it comes to OEM servers, cloud offerings, which are powered on AMD. So today's scenario, if you look at the AMD, the processor market in general, AMD is very well placed when it comes to gaining market share. They have been continuously gaining market share in the x86 platform since early 2018. And in the last 2 years, approximately, they have pretty much able to capture 20% of market share from Intel. This is in the server market share, but if you look at CPU in server market share, but if you look at even GPUs today, they are very well placed in terms of competing with NVIDIA in the GPU market. And in desktop, they are pretty much in last 15 years, first time in 15 years, they have overtaken Intel in the desktop CPU market. So we see more and more enterprises or enterprise computing be powered on AMD CPUs. Just to give you an overview about where AMD is from a CPU perspective, today they have start from laptops to data centers or servers in data center. Some of these systems are powered by AMD today. So from a PC perspective today, some of the large PC manufacturers like HP, Lenovo, their laptops and desktops are powered by the AMD Ryzen Pro processors. From a data center platform perspective, AMD is powering many HPC servers today, and they are one of the fastest growing GPU vendor today with their AMD Instinct MI100. Similarly, in the server portfolio, they have AMD Epic CPUs, second gen, and we're going to talk about the third gen, which is powering some of the powerful systems. And from a workstation, the enterprise workstation, they provide the AMD Threadripper Pro processors and AMD Radeon processors. Now in AMD Epic has been there quite some time. They power one of the world's important workloads today. So if you look at the exascale supercomputer era, or if you look at some of the large cloud services today in the market, they're all powered by AMD CPUs. The reason AMD is able to provide we see a lot of adaptations around this is the superior or the superior total cost of ownership what AMD brings to customers with all the added features when it comes to providing the right security in a cloud or even for enterprise application. So AMD provides the performance that is required. We're gonna see what is the kind of performance AMD is able to bring to the market, to customers compared to the other competition. The scalability and the security features start from data center to the edge to the market. So AMD recently has introduced the third generation CPUs, which is the AMD Epic processor, which is based on the Zen core architecture. Now, this is one of the best CPUs when it comes to performance per socket per core, which provides 19% more instruction per core compared to the second generation AMD Epic processor. And it's able to provide and it's providing the performance across some of the high performance, some of the workloads like high performance cloud and the enterprise application. So it provides a low latency, which is a significant accelerator for HPC and cloud-based application. With the Zen core architecture, it is providing 2x L3 cache, which is directly accessible per core. So better performance for some of the large virtual machines that are running in cloud, for example. It provides the right kind of throughput which is required for workloads like AI inferencing. Uh, it provides the core complex. It provides 8x core complex instruction per clock, which uplifts the performance of the overall system. Now, this is some of the comparisons in terms of AMD CPUs are performing. We're talking about the Gen 2 and Gen 3 here, how AMD CPUs are accelerating HPC workload. Right. So if you look at the floating point performance on two processor compared to 28 cores, which Intel is able to provide, and if you compare this with the second gen AMD Epic processor, 64 core, and furthermore with the latest third gen, we're able to get more than double the performance from AMD Epic processors for an HPC environment, which is accelerating some great scientific applications what customers are running. Similarly, in cloud, if we compare, AMD is able to provide again double the performance compared to a Intel CPUs, which is running in the cloud. What it means is that customers are able to run, or the vendors or the cloud vendors are able to run, provide more intense, more dense machines on their cloud, right? Which helps in scalability in cloud. And similarly, for an enterprise application, for enterprise customers or CIOs who are planning to deploy or who are deploying the enterprise application on AMD infrastructure, they see more than 117%. 17% more, 117% more performance from AMD powered CPUs. So these benchmarks at the moment. These benchmarks are based on the Java virtual machines, right? Which is some of the enterprise applications. And for users running virtual desktops. Now, virtual desktops has been the adaptation of virtual desktops have grown in last couple of years, and it is one of the uh, uh, critical application today for businesses, right? Because they are running all the users on virtual desktops. So here is some comparisons on using Login VSI. Login VSI is an application used for benchmarking. And this application, what they have simulated here is the number of user sessions on 2P Intel Xeon, the 6000 series versus an AMD Epic processor, the third gen, and they've compared the performance. And what they see is that AMD CPUs is able to power or are able to run more VDS sessions, more than double compared to Intel, right? So this is a clear value for money in terms of powering up or bringing up more performance to the infrastructure where customers are running their mission critical applications. This is another comparison on the performance that I mentioned. So compared to the 28 core Intel versus the 64 core, a login VSI benchmark performance, which is 112% more sessions compared to Intel. Now, these are some of the processors that are available today with third gen AMD Epic processors. So start from 8 core to 16 core, 24, 28, 32, up to 64 core. So multiple options available for customers today looking for alternative options, looking to reduce the total cost of ownership and getting a complete ROI from the investment where they want to get the best performance out for their enterprise application. Apart from CPUs, AMD has got AMD Instinct, which is a GPU graphical processor unit, which competes directly with today with some of the vendors available in the market. One of these vendors is NVIDIA, who had last year launched the AMD A100 GPUs. Now, if you look at the performance for some of the workloads like AI or machine learning, and high performance computing where you use GPUs, right, we would see that AMD is able to provide, or the AMD Instinct MI100 is providing more than 100% increase in the performance. So so this is just some of the comparisons on some application, but of course there are customers using other GPUs for AMD for other type of workloads, and even on those GPUs which are used for desktops, they provide far superior performance than other competition available in the market. And when we look at workloads for AI or machine learning, AMD is able to also provide the exascale platform, which is used for accelerated computing. So they provide all the kind of they provide all the software libraries and the frameworks which are compatible with many applications today. Many applications are be certified on their framework and the libraries. And so they provide an end-to-end solution, start from the toolkits to frameworks, libraries, to the device itself, which is the GPU. Now, some of the most powerful exascale supercomputer today are powered by AMD, right? So we're going to look at some of these examples here. So when we look at exascale, so anything that solves some of the toughest. So these supercomputers are some of the what they solve is they solve some of the toughest challenges today in the world. So these supercomputers are able to simulate models and some of the advanced understanding in terms of interacting with underlining the science of weather, for example, atomic research, atomic structures, genomics, physics. So some of the very complex workloads, like for example, uh, uh, today supercomputers have been widely used for research, say, in biomedical. Right. So in biomedical research, there are teams that are investigating, let's say, protein engineering to enable new types of industry, design new pharmaceuticals, medical therapies in order to improve the human lives. Now, similarly, these are computers being used during COVID by researchers to do researches in terms of bringing up new vaccines or finding new solution in terms of treatments. So these are the machines, these are powering some of this heavy workloads today. Similarly, in climate science, if you look at, there are scientists who simulates the behavior of, let's say, the oceans and the atmosphere, and they build models that abstract climate change. This helps in understanding what they need to do to keep the earth nurturing and in a hospitable place. Similarly, if you look at material science, there are scientists that are studying the nature of materials at a smallest possible scale, from power generations and transmissions to the production, to bring it faster, make it smaller and more versatile. Right, so these are so widely been used in research and education, where they are where you need more compute power to for faster results, and this is where you need more faster processors, you need faster GPUs, and some of these examples is the world's couple of examples where AMD is being used widely. In this case, Frontier, which is one of the supercomputers used by U.S. Department of Energy in Oak Ridge National Laboratory. And this supercomputers are delivered are expected to deliver a performance as 1.5 exaflops. And this system is supposed to be online now, mid of 2021. So these are custom-built supercomputers, which are where AMD has customized the Epic processes and they have optimized it for running some of the HPC and AI workloads with this laboratory or the department is using. Similarly, they have used the Radeon Instinct GPUs, which has been again customized to run these kind of workloads. They have another customer, the El Capitan, which enables 2 exaflops, which is double precision processing power for Department of Energy, Lawrence Livermore National Laboratory, and AMD in this case powered up with HP, or they teamed up with HP to design this supercomputer. And these supercomputers are expected to be delivered in 2023 using the next generation AMD processors, which is codenamed as Genoa, and it supports the next generation memory and the IO subsystem. So this is something that AMD is already planning in next 2 years to build a supercomputer, and this would support the new generation, which is supposed to be launched in 2023 with the the new generation of memory and I/O modules. And it also supports the new generation of GPUs are going to be supported on this supercomputers, which are optimized for HPC and AI workloads. AMD provides one of the best performance as I shown you, and the scalability that is required to run some of the critical applications on cloud, and some of the applications that we use on day-to-day basis, like the Office 365, Microsoft Teams, the Tencent meeting, Twitter, Zoom. These applications are today powered by AMD CPUs on the cloud by these vendors. And if you look at the other cloud service providers, where we have the AWS, the infrastructure as a service, to be specific. Some of these services are being cloud by AWS and Microsoft Azure. They use AMD, and there are more than 200 plus instances on the cloud which are powered by AMD Epic processors. And there are AMD being used widely by some of the private cloud vendors who build hyperconverged infrastructure solution. Similarly, we have vendors like HPE, Hewlett Packard Enterprise, Microsoft, Nutanix, VMware, who have built their hyperconverged infrastructure solution, which is providing more than 180% higher performance on a VMware infrastructure, where you're using hosted this on a VMware hypervisor on a vCenter cluster, on it 2P AMD Epic processors. Right, so we have today AMD has been widely used on hyperconverged from HPE, the nimble and the simplicity, the two known model available from HPE. For Microsoft, they have the Dell EMC Azure Stack HCI offering. They also have the HP Microsoft Azure Stack, Dell EMC VxRail, Lenovo Think Agile, and vSAN Ready Nodes. These are some of the hyperconverged solutions available powered on AMD. So I've come to the end of the presentation. I would like to open this forum for Q&A. If anybody has any questions, could unmute themselves and we'll be more than happy to answer. Or if you can drop questions on the chat, I can answer them.